Thank you. I hope everybody can hear me, and I guess my slides are going to come online very soon. So the story of this talk, I see that there was a typo here on this first slide. There's been a swap in the file. The story of this talk is exactly what was introduced here. There's a lot of data now in energy systems, and a lot of researchers are focused on this digitization for energy systems. And when we think of digitization, typically our first reaction is to think, okay, I'm just going to gather all the data I have available. I'm going to do some analytics and I'm going to generate some value, right? But we somehow make a very strong assumption that people somehow will be willing and able to share the data. They may not be able because we don't have the communication channels. And you could say, oh, today it's not an excuse. You know, there's so much technology, we can have the communication channels. It's not always the case. And then they will be willing. And there, I can tell you in practice, most of these people are not willing to share the data. So that's what I want to discuss today. And there is quite a lot to go through. I put a few slides here about me if you want to look at them when the slides are shared, if they are shared. But this is not the most important thing to discuss. And let me go next. I cannot really see my slide anymore now. I only see a timer. I don't know who controls the view. Thank you very much. Good. So now we're going to go directly to the why and the how of collaborative and market-based analytics. This is the title of the talk, and this is what I want to introduce today. I see it as a new field, and through the presentation, I will explain you why it's actually not a new field. There are so many works going in this direction, but somehow it's something that we should look at from a more holistic point of view. All these opportunities we have with distributed data, where we want to incentivize collaboration, we should see it in this framework, which I think will be a new framework where a lot will be happening in the coming future. And actually, the talk after mine about federated learning is one version of this collaborative and market-based analytics. So the point is that it's not just about energy. You could say like, okay, if there is a lot going on with energy, with data in energy system, then maybe, you know, it's a very niche type of application, and we could find some dedicated solution that are ad hoc, but still working. The thing is that all this kind of momentum is not just for energy. This starts with this idea of smart. You know, everything has to be smart today. We hear about smart energy, so that's what we're here to discuss today. It's more generally into smart cities, and into smart cities, there are so many things that relate to digitization. The smart transport, I mean, beside energy, if there's one field where there's I'd say some crazy thought and vision about some kind of revolution, I would say it's transport. When we go towards autonomous transportation, you know, self-driving vehicle, we won't own cars anymore. You know, we just call it with a mobile phone. It comes as a taxi, etc. Agriculture, we don't talk a lot about agriculture, but there's also a quiet revolution there that relies on digitization. And then Industry 4.0, I think we all have heard of so many examples related to logistics, related to manufacturing, etc. So everywhere there is this kind of push towards profiting of digitization and finding a way to be smarter in the way we operate systems. But the thing is that every time we hear this word smart, and this relates to digitization, in practice, it's about data and analytics. Data, we need to collect a lot of data, and we need to be sure that this data is useful, right? A lot of the work when you do data science is about cleaning data, you know, making sure that there's no holes, that the data flow as it should, right? So data has to be prepared in a certain way if we want it to be valuable. But the value of data is only revealed through analytics. You know, if you just get data on a computer, it's kind of worth nothing. But if you get this data into the right analytics tool, that's where you generate value. So all this aspect of smart energy, smart cities, etc., will eventually just rely on data that is put through some analytics task. But what's the value of the data? We don't know. And that's one of the key issues, is that we don't have a mechanism that can reveal the value of data through analytics. Though we have a few examples, there's a few companies out there that have already developed the machinery to generate value from data at scale. Because you can find a lot of small companies in different fields, that develop algorithm, profit of digitization to generate value from data. But you could say it's not at scale. If you look at Facebook, Google, Amazon, etc., they've developed a business model where they systematically at scale generate value from data. And that makes that 4 years ago, The Economist published this very nice article. I think that was a bit thought-provoking, with this funny caricature that data now is more valuable than oil. And I think it's not just a joke to be a bit provocative, it's a fact. If people know how to generate value from data in the future and do it at scale, data definitely will be more valuable than oil. But how do we get there? We don't really have the mechanisms to get there today. And that's what I want to discuss in practice. Looking at analytics, there's been two big trends. You could say there've been more of these trends, but if you look at the two big umbrellas that have gained so much momentum over the last 20, 30 years, it's big data. Big data relies on this idea that we collect so much and so quickly data every day. I note here, I think today it's order of billions of gigabytes per day. And it's going to increase. I think the projections are we could triple that within 5 years and multiply that by 10 to 20 within 20 years. And so there's been this big effort, research stream on big data analytics, and this is there to stay. I mean, we have to develop methods that can do something, that can manage to navigate within data lakes, quantities of data that are just astonishing. And then the second trend is edge computing. And this actually came before big data. People already in the early 80s realized that in the way we're developing computing architecture, starting to collect data, maybe it didn't make sense that we try to centralize all the data to do computation, to solve some tasks with computers. We could find somehow a balance between what can be done at the edge, right, in a decentralized fashion, and what could be done in a more centralized fashion. And I think this research field blends nicely into communication science. And there's been also a very big, I'd say, there's a lot of nice results from there that are going to be usable to rethink some of digitization and the economy based on data. So today we talk about edge, cloud, and fog computing, right? Okay, but are we not missing something? All those things are related to quantity, decentralization, but let's say it's at the technical level. We have not thought yet about the agents that are involved into this data collection and the analytics. And so the remaining gap there is that the ownership of the data is also distributed. And the agents that own this data, they have very heterogeneous preferences. Some are obsessed with privacy. You could think of us, as small people. We're not very happy that our data is being shared. Maybe some other type of agents that collect data are not so worried with privacy. There's competition in many fields. When people collect data and they could share data, actually this would be with their competitors. So maybe they're not so willing to share data. We've discussed that before. And then, yes, this willingness to share could be also related to some form of bounded rationality. Some people may have an interest in sharing, but they just don't want to, right? And you could go on like that in terms of heterogeneous preferences. So the proposal there, which we have seen in so many other fields, is to actually rethink these aspects within an economic framework. So that doesn't mean we're going to discuss economics today, but it's more, there's been different fields of mathematics and computer science where we say, okay, when we're going to rethink these algorithms, this way to work with data or with problems, we're going to think it in an economic framework. And this proposal with computers has already been made 30, 40 years ago to say, I think that in the first vision that was proposed, they thought it would already happen today, that we would have AI, so AI agents, you're in your house or everywhere, and that these AI agents would already somehow interact within a market with each other for a social objective, to improve social welfare for all the people involved. I don't think we're there yet, but still we see regularly papers coming out in some extremely good journal where it is the vision, right? That we're going to reach this stage where you would have AI that interacts for you in an economic environment and for the social good. Good. So what does it take? I want to give you a motivating real-world example. It's an energy example to show why we should do it and how it would work. So the context here, which is something I've been working with for the last, also 20 years, it's participation of renewable energy in electricity markets. And here we look at wind farms. And typically when wind farms sell their energy in electricity market, they have to do it in advance. And so they use forecast, right? So you see here, you have 3 wind farms, wind farm A, B, and C. And they're going to use forecast to place their offers in the electricity market. And then based on these offers, there's going to be a clearing of the market. And the green arrow you see there is going to be the revenue that come back. The thing is that the way electricity markets are designed, which makes sense, the revenue is going to be linked to your forecast accuracy. So if you have a very bad forecast, most likely you're going to have some penalties from the market and a lower revenue. So you have an incentive to improve your forecast. The best revenue can only be obtained with the optimal forecast, the perfect forecast. So all these wind farms have an interest in improving their forecast. And how could they do that? Actually, if they were sharing data, there's been many publications that show that if you could use data from neighboring wind farms, that can be power, that can be methodological measurements, that can be something else. If you were to use data from others, you could actually improve your forecast. So you would expect that all could benefit from this kind of collaboration. But as of today, because they're in competition in the electricity market, they don't want to do so because they are worried they may actually lose some revenue because of competition or just by principle, they don't want to share. So the idea is that we want to design this framework with collaborative and market-based analytics that would make that they feel okay with sharing their data. And it's not just about a feeling, from an economic point of view, if this agent are rational, they would actually realize this is a good deal for them. So see here, an example would be that wind farm B is aiming to improve forecast to get better revenues. And wind farm B goes into a distributed computing agreement with wind farm A so as to use data of wind farm A, but without ever sharing this data actively against payments. And then wind farm B could actually get data from wind farm C against payment that can be used also to improve the forecast. So what happens? Wind farm B with the distributed computing agreement and data sharing agreement will get better forecast. So wind farm B will have a better revenue from the electricity market. Wind farm A and wind farm C, they will get an extra revenue from wind farm B because of having shared information or help with computation. So if you look at that as an equilibrium analysis, you can actually show there's going to be increased social welfare, they're going to have increased revenue, and also overall the social welfare is increased. So that means the consumers on the other side will be benefiting. So it's a win-win-win situation. However, in practice, we don't have this kind of paradigm, this kind of mechanisms for collaborative and market-based analytics. And it's really what's the missing link, you could say, is that we have to blend analytics and mechanism design. I think until recently, there were topics that were really looked at, independently. There's a bit of a wall in between. So you have extremely good people that do machine learning, that just use data to try to do analytics and generate value. And you have these people that design mechanisms in terms of how we make sure that agents behave the right way towards a social objective. But blending the two together, it's only very recent and there are very, very few papers. But if we manage, this is something that has broad, you could say, perspective in terms of application, because the generic method that can be proposed are not just valuable for energy. You could use it for anything, for any field. You could even claim that in the future, we could value your data that is used by Facebook, by Google, etc., on the fly by having this kind of market-based analytics. But the thing is that maybe it has not come yet because it is very difficult. There's a lot of things to focus on. First of all, it's a very multidisciplinary endeavor. There's a lot of applied math and computer science, but you also have to bridge the gap with application. You have to think of it. Normally, when you play with data, you mainly focus, or let's say you do more machine learning, you focus more on the machinery that you want to develop to improve regression, forecasting, classification, etc. But here you need the link to application because the data come from there, obviously. But also if you want to think of this valuation of the data and trying to find the right value and the right sharing of value through analytics, you need to understand what's happening on the application side. Then there's the data and analytics core. We know the nature of data for all of us that do machine learning. You know, the data is streaming, it can be shared in a synchronous manner, the setup are necessarily distributed. And there's still some room, you know, for development. For instance, if you want to do online distributed learning, there's not so many, in an asynchronous communication setup, there's not so many methods that exist out there. But also, most importantly, as I said, we want to blend the analytics with the mechanism design. That means that we may want to rethink the analytics also in a market-aware framework. So think of it, if you do some distributed learning, for instance, the way an agent may be willing to make some operation, computing operation, may be a function of certain type of payments. So instead of just assuming that the agents are going to do the computation they ask for, we should try to think, you know, what would they do depending on the payment they get, right? And there's so many ways we have to think of it. You could also think of the fact that when agents share their data, they will modulate actually the quality of their data or the truthfulness of their data as a function of how much they are paid. And then we have to find the equilibrium there. Finally, there's the issue of the mathematics of markets. There's many aspects when we do mechanism design for this analytics and data that is very different from what we have done for other type of commodities. There are a few examples. For instance, the value of the data may not be known at the time, for instance, you may bid in a market. So what do you do when the valuation of your product is uncertain? We don't have so many market design for this kind of thing. There may also be delays, right? If all the agents come on the fly and you need to clear the market to find the value of the data or how the features are going to be allocated to different agents, but it's on the fly, maybe we don't have the machinery to do that as of today. So there's many aspects to rethink. And also in terms of mechanism design, as I said, since this kind of market for data and analytics will definitely be linked to other type of markets or mechanisms in the application areas, we also have to think of it as an equilibria between this machinery and what's happening in the application area to be sure it's beneficial. Okay, just let me give me a few examples here of a platform or how it could look like. And then I want to show you a practical example that you could consider as analytics market. So what would be the outcomes? And actually, you will recognize some things that already exist today, but I want to put it in a perspective. So we're going to talk about analytics platform. You know, eventually, whatever mechanism design, you know, new analytics we do, somehow in practice, what would happen is that we would have these kind of platforms online for analytics where people could post some analytics tasks and some others could say, okay, I'm going to help versus payment or not, you know, you can use my data or not, etc. So there's already a few of these platforms, I think, that are emerging today. There are three types of platforms here that I consider. The first one on the left, it's collaborative analytics. And when you do collaborative analytics, you have a central agent, so here on the top, that has an analytics problem at hand. And this agent knows that he or she could better solve the task by using data of others. But the support agents that are below, that have this data, they don't want to share it actively, right? So instead, for the central agents, the problem is split. So it can be a regression problem, classification, you know, trading, whatever, any form of optimization problem. And this problem is decomposed. Some sub-problems are sent to the support agents. They solve their sub-problems. They send it back to the central agent or to the platform. It's all fused together, and eventually the central agent gets a better solution to the task at hand. And this is federated learning. This is a type of collaborative analytics. We have also proposed some other form of collaborative analytics, and some other groups around the world have proposed this kind of thing. So this is one version. And as you've seen, for instance, for federated learning and the others, we want potentially to add a privacy layer here, because even though the support agents don't want to share the data, the fact that this iteration between them makes that you can actually have an attack model to try to recover the information from the support agent. So at the opposite, data markets, here in the middle, they may be there so that you actively share the information from the support agent towards the support agent. And there, based on this sharing of information, we need a mechanism to value the data, and we then price this data and give the money to the support agent. And eventually, it leads to the right to this analytics market, where we blend all these concepts together, and we try, as the motivating example I showed you, to have some parts about data, active data sharing versus payment, maybe distributed computation versus payments, etc. So there are many aspects. Here, you could go one by one through this mechanism. That's the three I showed you. And there are many aspects here that require a lot of methodological research. So there's different blocks of methodological research one needs to look at. There's the analytics. I was telling you, streaming, asynchronous distributed data, market-aware analytics. There's the market themselves. We're in high dimensionality. We need approximate clearing since we are not really sure of the value of the data, but also it might be too large anyway for we solve the optimization problem. And eventually, we also need this new mechanism design. So to finish my presentation, I want to give you a very simplified example in practice of what could be done. And this is, oh, sorry, I'm just going to skip that. Right. So this is the regression market, right? So regression market is a central agent, for instance, that want to fit a model for forecasting, and it's a regression model. So you may want to use machine learning, you may want to use some other tools. Okay, so you have a central agent that has a regression problem. For instance, I say here it's applic that want to forecast the demand for a group of customers. And this central agent fits a regression model to do some forecasting and gets, here you can see with least square estimation for fitting the model, it gets a score function S omega, and S omega star is the optimal score function you can get when you get the right model. But then Air Liquide knows that they could improve their forecast by fitting a better model by using data of others. And it posts a task on an analytic platform and say, I have a willingness to pay of 100 euro per % improvement in my score function. So when this task is posted, you could have two support agents that bring two extra features, Z1 and Z2, Z1, Z2, and they want to be remunerated for it. So we augment the regression problem. That's the line you see here in the middle. And eventually, when we fit this augmented regression, we can get a better score value. We're going to have the coefficient that is associated with the features. But if there is a better score value, that means that somehow the central agent, Air Liquide, is getting something out of it. And we need to have some kind of payment. So in terms of payments, it's actually very easy in this kind of framework to define some payment because we play with convex loss functions. So as long as we have convex loss function in a learning problem, so that can be for quantiles, that can be for the mean as here, it could be some other type of learning problem, we know we can define some proper mechanisms to make sure that we have the right property as we want to have in the market. So here, for instance, we can have this kind of payment here, pi j, where we have the willingness to pay of the agent, we have the improvement of the score for the regression fit, and we have this feature evaluation. And this feature evaluation is nothing else, for instance, than a Shapley value that tells what's the contribution of this agent to better explaining somehow the why, so the response variable of the central agent. And so then we have a payment from the central agent, here at Liquid, and we have a revenue from the support agent. And we have all the nice property where we want to have in the market. It's going to be budget balance. So sum of revenue equals sum of payment. It's going to be symmetric. So there's no differentiation among the agents. You know, if they bring the same contribution, they have the same payment. We have a zero element. So if you don't bring anything, you don't get paid, etc., etc. So this is a very simplified example, but it shows that we can very easily design markets for data and analytics. So to conclude, I wanted to cover this idea of a new field, collaborative and market-based analytics. And I think it's the missing link to efficiently and fairly generate value from all this distributed data. There are lots of research to do. So anyone interested, and I think there are many groups interested in this kind of idea, so we should get to work. And just as a conclusion, as I was telling you, there's been already for 20, 30 years some vision about AI interacting in an economic framework. But I think the most important vision is the one of Noam Nissan and Amir Ronen in 99 when they defined algorithmic gauge theory. This is one of the most interesting applications. So thank you very much.
Excellent. Thank you very, very much for this very interesting talk. I think now we have a bit time for questions and answers. As a small address to the audience, please feel free to use the question and answer section on the socio framework such that I can then ask the respective questions to Pierre Pinson. So far, no questions have been entered. So let me start with the first one. You explained very well that collaborative markets have a huge benefit to support the energy turnaround. On the other hand, we don't see these markets being in place. So could you potentially draw a short roadmap on how can we achieve these roadmaps? Or you mentioned before, there is some research missing. So which would be for you the first cornerstone to be tackled, the first answer to be found in order to foster this energy transition?
Yeah, so first of all, I mean, there are research projects that focus on that. I'm part of an EU project called Smart Forests, where we are designing markets for energy applications, and it's forecasting there, the application. So I think what's really important is to actually get industry and practitioner to realize that this exists, because often, maybe the first and main issue is that the people in the field, they don't really realize that this new concept really exists. It's not just theoretical. And we are trying to develop some prototype of a platform that would allow in a flexible manner to do this collaborative analytics and market-based analytics. So I think it's the first step. I think the second step is actually to focus on the business to show that there is value there.
Cool. Thank you very much. In the meantime, we had a first question from Baroli Barahona. He would like to ask on slide 17, in this example of air liquid and cold water, what happens if those two companies would be competitors?
So that's part of what I was just saying for business cases and what I mentioned during the presentation with the equilibria between this kind of market and the application area itself, right? So for instance, we have an electricity market and we have a data market, let's say, or an analytics market. And you want to be sure that when you bind the two together, everybody benefits, okay? So here, for instance, that means that if one of the support agents share their data and they're in competition with Air Liquide, the payments they would get for sharing their data should be more than what they're worried to lose if they were to lose competitiveness, right? And that's where we need to do a lot of theoretical work or mechanism design work, because it's quite difficult actually to guarantee these properties when you try to combine markets together. One way would be by focusing on how the agents, so the support agents here, they value their data when they want to share it. I simplified the example. I said only Air Liquide had the willingness to pay. But you could also declare on the support agent side a willingness to sell. And they would say, for instance, if you pay me less than 50 euro per, I don't know, per data point and per something, then I'm not sharing. And this would be somehow to be sure that they cover at least what they believe they could lose in terms of competitivity.
Cool, thanks a lot. Then there has been an additional question from Alina Walch, asking what happens if one of the features from the external agent is only useful in combination with another feature from an external agent. So what happens if you need two parts in order to fulfill this data demand, and how could you then attribute the added value of the respective features? What would be your suggestion there?
So it's a very nice question. Here I show it in a very simple linear setup, but already in a linear setup, you can have collinearity between features. So that means that somehow they kind of partly explain the same thing. And then in more complex models, you may have some interaction terms. So somehow some features only have value by being combined with each other. But there's a lot of work in the machine learning community related to interpretability so that you can assign some contribution to each and every feature and to make it in a way that it's really, you can separate and it's additive, etc., like the Shapley values that I mentioned. So this is the way to go. Normally, these tools can be readily used and it just works in practice.
Excellent. There has been a question from Josef Kamleitner. He asked whether you know the Data Market Austria initiative or comparable initiatives in Europe and how that would compare to your suggestion. So are you more focusing on analytics part or what would be the difference to it?
So I agree. There's been a few, and there are a few today. There's been a few before of these data markets, and some are very good. Often they focus, or what is good is one of the aspects only. So we had one data market in Copenhagen, for instance, but this data market had no real clever way to clear the market and to value the data on both hands, agents that sell and agents that buy. And that made that actually didn't work and they stopped the experiment. Then there's this data market, for instance, by IOTA, which is a very nice idea in terms of the architecture, but then there's no their intelligence in terms of the clearing or in terms of the evaluation of the data, right? And then you can continue like that. There's quite a few initiatives. I think these initiatives are really great, but they are still prototypes. There's still quite a lot of work to do to make sure, that we have the right methodological background and theory to support somehow the claim that these are the right type of markets for data sharing and for collaborative analytics.